Okay, so this is the 2023 Higher Level Junior Cert Maths paper, question 14. The diagram below shows the triangle ABC not to scale. The points D and E lie on AC and BC respectively. The angles at CAB and DEC are 90 degrees. Some of the lengths are shown. Work out the value of x. So if we look at x here, it's one of the sides of a right angle triangle. We have two of the sides, so we can just simply use Pythagoras' theorem. So 15 is the hypotenuse, 9 then, and x, which we just square and add. So if we just bring the 9 over, we get 15 squared minus 9 squared, and then square root both sides. That gives the square root of 15 squared minus 9 squared, and finally that will just give us 12 if you do that. So we now know what this side here is. X is 12, and this is 12 here as well. Second part, use similar triangles to work out the value of y. Okay, so the two triangles that we're going to talk about here are this small triangle here and the big triangle here. A good idea when you're doing these kind of things, when a triangle is inserted in another triangle, is to redraw them in the same orientation and put in all the labels and lengths of sides. So I'm going to do that. So I'm going to draw the big one first. The big one is ABC. So let's draw that first. So A, B, C. Oops. So let's see where all the labels go. So A and V are down at the bottom. So that's A, that's B, and that's C up there. Now, we're told here that x and x make up the hypotenuse of the big triangle. So we know that x is 12, so BC must be 24. So this distance here must be 24. We know down at the bottom we've got y, and we don't have this side here. We only have part of it, but we don't know how far down it goes. So we only have y at the bottom. So that's one triangle anyway. I'm going to draw the smaller triangle now in the same orientation. So the smaller one has a right angle at E, and D is out here, and that must be C then up at the top. So this is C. So the size that we have there, the hypotenuse is 15, so this is 15 here. The 9 is on the bottom and the other side is x, so this is 9, and we know that this is 12 from what we've done earlier. Now it says using similar triangles, so I'm not sure if they're going to require us to prove that these two are similar, but I'm just going to run through that quickly anyway. What we can say to prove that they are similar is that angle CAB is equal to angle CED in the other triangle equal to 90 degrees. We're given that in the question. So these two angles here are the same 90 degrees. We can also say that ACB, the angle ACB in this triangle here, this angle here, is equal to angle ECD in this triangle here. Why? Because they are a common angle. Therefore, we can say then that the other angle must be equal. So angle CBA is equal to angle CDE. Why? We can just say angles in a triangle. They add up to 180 degrees, so if you can prove that two angles are the same, the third one must be the same. So therefore, triangles CAB and CED are similar. So that would be the proof that the two are similar. So once they're similar, we know that sides are in proportion in order. So we can say the hypotenuse on this triangle, the 24, divided by the hypotenuse on this triangle, which is 15, is equal to, we need to work out y, so we're going to include y on the big triangle, must be equal to 9 on the smaller triangle. So cross multiply then, so you get 9 times 24 equals 216, and that's going to be equal to 15y. So all we've got to do then is divide by 15, and that gives 14 14.4. So that's our y there. And that's it for this question and this paper.